Now, students, we will start from 9:35. Huh? Let some other people join as well, and then we will start. Orgo, no need to give the attendance in the chat box. We will have the IMC here per exam. Okay, good morning, students. Let's start then. Let me share my screen. Okay, yep. So I hope my screen is visible.
Yes, sir.
Okay. Okay, so in today's class, whatever we will study, just try and listen very carefully. If you have any issues, kindly ask me in the middle of the class, because whatever we are going to study today is very difficult to make you understand without the use of chalk and board, right? Just by making the use of PPT, I don't know how will I make you understand. But still, let us try. If you have any issues, kindly tell me in the class only itself. Okay. So, if you remember that we were doing the data link layer, and the main two functions of the data link layer were error control and flow control, right? Now, in the error control part, we had the error detection and the error correction. So, for the error detection part, we have studied what is Hamming distance. We have studied some methods: 1D parity check, 2D parity check, checksum, CRC, right? And for error correction, we have studied one method, and that is known as Hamming code. Okay. Now, obviously, we are completed with the error control part. Now, we will move to the flow control part. Okay. Now, what do we mean by flow control? Let us understand first. Okay. So, flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for an acknowledgement. Now, just understand what happens. That suppose there are two computers, one is the sender and one is the receiver. It may happen that both the computers are having the same bandwidth or are capable of having the same bandwidth. What's the bandwidth? Bandwidth means the amount of data, or amplitude, which means the amount of data that can be sent in 1 second of time or one instance of time. Okay. So suppose computer A has computer A and computer B has the same amplitude and the same bandwidth, which means whenever computer A is trying to send data to computer B, there is no issue in the data transfer, which means computer A is sending at the same pace, computer B is receiving at the same pace. Okay, because the amplitude and the bandwidth are the same for both the computers. It may happen that computer A has a higher bandwidth and amplitude with respect to the second computer, computer B. So in that scenario, what can happen? That a computer A is sending a data at a much higher rate than what the computer B can receive, right? Similarly, in the third scenario, what can happen? Computer B suppose has a higher rate of receiving the data, and computer A in that case has a lower rate of sending the data. So in that scenario, what will happen? The data computer A will send, so obviously it will send the data in a slow manner. Computer B will have no issues in receiving the data, but again, since the bandwidth of computer B is much higher, which means it is capable of receiving much higher amount of data. So in that scenario, the bandwidth and amplitude of computer B is being wasted. Okay. So again, if we say that the rate of sending data and the rate of receiving data are the same for both the computers, it is fine. But again, if the rate of sending data for computer A is bigger than B, then it's a problem. And again, if the rate of receiving data for computer B is larger than the rate of sending data of computer A, then again it's a problem. Okay. Now, to mitigate this problem, what we do, we have come up with some protocols, and that are part of nothing but something known as a flow control. Okay. So we can control the flow to match the data flow or data rate of flow of data between the two communicating computers. Okay. So is the introduction clear to you? Kindly ask me question if you don't understand it. Anyone? Yes, no? Anyone, if you can answer, because again this is important. Yes, okay. Anyways, if you don't want to answer, no issues, but again, if you have any issues, tell me, right? Okay. Now again, whenever we have flow control, we have two types of channel that we can use between two computers, right? So the first type of channel that can be used between two computers is known as a noiseless channel, right? Now if you remember, whenever we did the bit rate, baud rate, we have discussed the issue of noiseless channel and noisy channels, right? What's a noiseless channel? Which means there will be no error, which means whenever we are using a noiseless channel, the chance of our data getting lost is very difficult, right? In a noiseless channel, no data will ever get lost, okay, during transmission, right? But in the case of noisy channel, a data may get lost during the transmission of a transmission phase between two computers, right? Okay, this is the first thing. The second thing is something known as an acknowledgement. Now what's an acknowledgement? Now suppose computer A is sending data to computer B. So after computer B will receive the data, right, it may or may not, it will depend on the protocol. So it may or may not send an acknowledgement back to computer A, right? Now after computer A receives the acknowledgement, he can send the next bit of data, right? Now everything I am saying will depend on protocols, right? For some protocol, it may happen that computer A, after sending data, will wait for an acknowledgement from the computer B. So until and unless it receives the acknowledgement, it will not send the next bit of data, right? But in some protocols, it may happen that computer A will not wait for any acknowledgement. After computer A sends the data, irrespective of whether computer B has received the data or not, it will send the next data, right? So again, there is a concept of acknowledgement. Okay, and what is the concept of acknowledgement, we will see in some of the protocols that we will study today. Okay, now again, we said that there are two types of protocols or two types of channels. The first channel is known as a noiseless channel, where there is no chance of a data or an acknowledgement. Acknowledgement is also a packet, right? If a data is being sent from A to B, if that data is a packet, now obviously computer B will send an acknowledgement to computer A. Now that acknowledgement is also a packet, right? Now obviously in the case of noiseless channel, there is no chance of a packet getting lost during transmission. Now that packet can be either a data packet or it can be a acknowledgement packet, right? But in the case of noisy channel, what can happen? There is a high chance of the data that I am sending from A to B, as well as for the acknowledgement that is being sent from B to A, for getting lost inside a noisy channel. There is a high chance for that. Okay, so there are two types of channels, and for every type of channel we have certain protocols. Okay, so for the noiseless channel we have two protocols. One is known as the simplest protocol, right, and second one is known as what? Nothing but a stop and wait protocol. Okay, now again, we will just take this stop and wait protocol and we will extend it for the noisy channel, and in that scenario we will call it as stop and wait ARQ. Now what is the full form of ARQ? ARQ means nothing but automatic repeat request. Okay, now what do we mean by automatic repeat request? We will see whenever we will study that. Okay, now again, for noisy channel we have a stop and wait automatic repeat request, we have a go back N automatic repeat request, as well as we have a selective repeat automatic repeat request. Okay, so there are three types of protocols in the case of noisy channels. Now what are ARQ? How do they work? What's the difference between stop and wait ARQ? One and the same thing, but again we extend a bit for the ARQ part. So what is everything, we will see in the next slides. Okay, now so whenever we have noiseless channels, so let us first assume that we have an ideal channel, as we have discussed earlier. So let us first assume that we have an ideal channel in which no frames are lost, right? Now what do we mean by frames? The frames can be a data frame that is being sent from A to B, as well as it can be what? An acknowledgement frame that can be sent from B to A, right? Both the frames. So let us first assume that we have an ideal channel where no frames are lost, duplicated or corrupted. Okay, corruption means what? Suppose it's a 0, it can be a 1. What is lost? Suppose a frame is being sent from A to B, the frame never reaches B, right? Or a frame is being sent from B to A, but the frame never reaches A, right? What is duplicated? Duplicated means, suppose A is sending a frame to B, B has received it, but again A is sending the same frame, so B has to reject it. Okay, so these kind of things may happen, and we will see how. Okay, so it's an ideal channel where no frames are lost, duplicated or corrupted, right? And we introduce what? Two protocols for this type of channel. Okay, so what's the first protocol? It is known as the simplest protocol, right? Now obviously why simplest? Because it is the most simple protocol of all the protocols that we will see today. Okay, and again, the sender sends a sequence of frames without even thinking about the receiver. Okay, so as we were discussing earlier, it can happen that sender is sending the frames to the receiver and it does not wait for an acknowledgement from the receiver. Okay, if the receiver receives the frame, that is then it is fine. If it does not receive the frame, then it's the problem of the receiver, not a problem for the sender. Okay, so the sender, what it does is, it whenever it has a sequence of frames to send, what it does is it just sends the sequence of frames without even thinking about the receiver. Okay, just a second. Okay, again, to send 3 frames, 3 events occur at the sender side and 3 events at the receiver side. Okay, now what are the events? We will see whenever we will discuss the diagram. Okay, also note that the data frames are shown by tilted boxes. Okay, so again in the diagram that is at the right hand side, you can see that whenever we are sending data, we are having blue tilted boxes. Okay, so blue tilted box is nothing but we are actually sending the frames. Okay, and we will use this same concept throughout our class. Okay, so again, for every frame that we will send, we will use nothing but a tilted box. Okay, now note that the data frames are shown in tilted boxes. The height of the box defines the transmission time between the first bit and the last bit. Okay, so again, whenever we are suppose if we just see the sender part, so that is marked in A, and we have a arrow pointing downwards. This arrow is nothing but it's a timer. Okay, it's a time. Okay, so again, whenever we are sending the first frame, you can see that there are dotted lines in the arrow that is being that is coming from the sender A, right? And suppose if we say that for each dotted line it is 1 second, then again we can see, or we can say that for sending the frame from A to B, we actually take 2 seconds, right? Again, whenever we are sending the second frame, we can again see that for sending a frame from A to B, we again take 2 seconds, right? Again, for the third frame also we can say it is 2 seconds, right? So again, if I say that the dots are time instances, now again what it means, that the height of the tilted box that we are showing here is the amount of time the frame takes from going from point A to point B. Okay, now if you see the diagram that is below, right, you can see that whenever we are at the sender side, what happens is, suppose the thing marked in green is the data link layer. Okay, now obviously this data link layer will get a request from the network layer, right, and it will grant request to the physical layer. Okay, so just keep the OSI model in mind. We have not elaborated the diagram, but again just keep the OSI model in mind. So if the green part is the data link layer, the upper part is the network layer, and the lower part is what? The physical layer. Okay, now again what happens is that the data link layer will get a request from the network layer, and it will receive request from what? The physical layer. Okay, now at the data link layer, what happens is, whatever data, it means that whatever data is being sent from the network layer, right, what's the algorithm that is running inside the data link layer? Algorithm for the sender side is that repeat forever. Okay, so which means whatever data is being received by the network from the network layer, it will just send the data automatically to the physical layer, and through the physical layer to the sender B. Okay, and again at the sender B, again the same thing will happen. Receiver B, again the same thing will happen. What is that? That if the green box is the data link layer, so obviously it will receive data from the physical layer. Now again you can see that it is saying repeat forever. So which means whenever the physical layer will send data to the data link layer, it will always have to receive the data. Okay, so again there are two events for the sender side. Whenever we are receiving data from the network layer or from the upper layer, we will just send the data to the physical layer, and through the physical layer we will send it to the receiver B, right? And at the receiver B, what will happen? That whenever we will receive data from the physical layer, that is down to us, we will always try and receive the data that is coming from the physical layer. Okay, so this is nothing but the simplest protocol, where a receiver, a sender and the receiver, just before thinking of each other, it will just try and send whatever data it is given to by the upper layer or by the bottom layer, right? For the sender side, the data will come from the network layer. Whatever data comes from the network layer, it will just take that data and it will forward it through the physical layer to the receiver B, and whatever data comes from the physical layer of the receiver B, the data link layer of the receiver B will just accept that data, right? So that is nothing but the simplest protocol. Okay, we are not concerned about data loss, we are not concerned about data corruption, we are not concerned about data duplication, nothing. Okay, so this is for an ideal channel where nothing of this sort happens. Okay, right. Okay, next is something called as a stop and wait protocol. Okay, now it may happen that, again, if you remember, we have said that suppose a sender A is sending a data, right, but the receiver B is not in a position to accept the amount of data that sender A is sending, right? Which means, for example, if I say that the sender A is sending data at the rate of 10 Mbps, and suppose we are saying that the receiver B has a capacity to receive data at the rate of 8 Mbps, right? So it may happen that some of the data that A is sending may get lost in that process. Okay, so again, to mitigate this problem, what we do, we will have a concept called as acknowledgement. Okay, Now what's an acknowledgement? Let us understand. So the sender sends one frame and waits for feedback from the receiver. Okay. So what is the meaning of stop and wait? So obviously after sending a frame, I will stop. I will refrain from sending another frame immediately. I will wait for the receiver B to send me an acknowledgement, right? After I receive the acknowledgement, what I will do again, I will start sending the next bit. Okay. After sending the next bit, what I will do, I will refrain from sending the third bit. Okay. I will stop. I will wait for getting the acknowledgement from the receiver. So after I get the acknowledgement from the receiver, what I will do, I will I will actually send the third bit. Okay. So the sender sends one frame and waits for a feedback from the receiver. Okay. So when the acknowledgement packet arrives, the sender sends the next frame. Okay. Note that the sending of two frames in the protocol involves sender in 4 events and the receiver in 2 events. Okay. Now what are these events? Let us understand that. Okay. So at the sender side, again you can see that first and foremost it is getting data from the network layer. Okay. So after getting data from the network layer, what it will do, it will just pass the data to the physical layer, and through that physical layer it will pass the data through the physical medium to the receiver B, right? Now the receiver B, what it will do, so whenever it gets data from the physical layer, what it will do, it will receive the data. After it receives the data, what will happen? It will send an acknowledgement to the physical layer, right? The physical layer, now what it will do, it will send an acknowledgement back to the sender through the physical medium. The sender, now what it will do, it will receive the data from the physical layer. After receiving data from the physical layer, which means it will receive the acknowledgement. So after receiving the acknowledgement from the physical layer, the acknowledgement will go to the data link layer. It will check whether I have received the acknowledgement or not. If yes, then again it will take data from the network layer, and then again it will follow the same process once again. Okay. So again, see that the bottom diagram is not that important. It is just there for making you understand what is happening. But again, if you understand the diagram that is given at the right hand side, the bottom diagrams becomes logically very clear. Okay. So again, if you understand what is stop and wait protocol, stop and wait protocol means nothing. If you see the diagram again, you will be able to understand better that suppose there is a sender A, right? The sender A is sending the blue frame. Okay. So after sending the blue frame, what it does, it will stop. It will wait for an acknowledgement from the receiver B, right? And the receiver B, after it receives the frame, what it will do, it will send an acknowledgement back to the sender A. So after sender A will receive the acknowledgement, what the sender A will do, it will send the next frame, and again after sending the next frame, it will wait for an acknowledgement, and again after it receives the acknowledgement from receiver B, it will again try and send the next frame. Okay. So I hope I'm clear till this. So if I'm clear till this, the next portions will become a bit heavyweight. So again, you need to understand it better. Okay. Now we come to the noisy channels. Okay. Now what is a noisy channel? So although stop and wait protocol gives us an idea of how to add flow control, right? Noiseless channels are non-existent. Okay. So so in the noiseless channel, we have seen in the stop and wait protocol that again we are sending a frame, we are receiving an acknowledgement. We are sending a frame, we are receiving an acknowledgement. But it may happen that the frame that you are trying to send, due to a noisy channel, it can happen that the frame will not go to the receiver at all, right? It can happen that the acknowledgement that the sender B, that the receiver B is sending to the sender may not get delivered at all. Okay. Again, for the second frame, again it may happen that the request that the frame that the sender A is sending may get corrupted. Okay. And it can happen that the acknowledgement frame that that receiver B is sending may get lost. Okay. So these things can happen. In the case of stop and wait protocol, it does not happen because we are actually thinking it to be in a noiseless channel, right? But generally noiseless channels are non-existent. So again, it is not this simple as it looks in the practical environment. Okay. Now let us understand what happens in the practical environment. Okay. So although stop and wait protocols gives us an idea of how to add flow control, right? But noiseless channels are nothing but they are non-existent. Okay. Now obviously for noisy channels, we discuss 3 protocols, and they are nothing but stop and wait ARQ, go back in ARQ and selective repeat ARQ, right? So if you remember ARQ, I have said that it is nothing but automatic repeat request. Now what is this ARQ? Let us understand first. So whenever I am sending a data, right, from sender A to receiver B, it can happen that the data from sender A, some of the data has not come or has not been received by the receiver B, right? In that scenario, the receiver B can automatically send a request to the sender A to repeat either the whole data that sender A has sent, or it can request the sender A to send once again some of the data that receiver B has not received. Okay. Again, I am repeating myself. What is an automatic repeat request? It means that suppose we have a sender A and sender B. Sender A has sent suppose 4 frames to receiver B. The receiver B suppose has not received has received 3 frames. It has not received 1 frame. Okay, due to some error mechanism. Okay. Now after it fails to receive 1 frame, it knows that it has received 3 frames. So what it can do, it can automatically request the sender to send either the frame that it has not received, right, or it may request the sender to send all the frames that the receiver has sent. Okay. So whenever the receiver sends, whenever the sender sends all the frames, what the receiver can do, it can pick and choose, right? It can discard the frames that it has already accepted or already got, and it can discard the frames. It can discard the frames that it has already got, and whatever frame it has not got, it can just pick and choose from all the frames, and it will just accept it. Okay. So again, this is the concept of automatic repeat request. Now let us understand how it actually works. Now, so we have a stop and wait ARQ. Now again, if you remember, in the case of stop and wait, what happened, that if we are having frames to send, we will just send the frame, we will wait for an acknowledgement from the receiver B. After I receive the acknowledgement, then only I will send the frame, the next frame. Okay. Now just see the diagram that is at the right hand side. Okay. I hope the diagram is visible to you guys. Okay. So suppose in the first scenario, can you see my mouse cursor, everyone? If any one of you can say whether my mouse cursor is visible or not.
Yes, sir, it is visible.
Okay, so just follow my mouse cursor, okay, because scribbling anything through a pen tab in this diagram will make it very, make it you won't be able to understand anything. So just follow my mouse cursor. Okay. So suppose sender A has suppose 6 frames that it wants to send to sender B. Okay. So what are the frames? It is 0, 1, 0, 1, 0, 1. Okay. Now the receiver, obviously it will know that okay, the sender has 6 frames that it needs to send to me, and it will know the frame numbers, for example. Okay. Or suppose it can understand that, okay, what frames the sender will send to me. Okay. How it will understand, I mean, how the sender and the receiver will discuss the data that the sender needs to send and the receiver needs to receive, and that is dependent on max sublayer, IP address, TCP schemes, everything. So there are schemes for that. Okay. But now let us imagine that, okay, sender A and sender B both know that what data sender A needs to send and what data I need to receive. Okay. So again, so suppose sender has 6 data frames to send, and what are the data frames? It is 0, 1, 0, 1, 0, 1, and the receiver, again, it knows that it needs to receive 6 data, and what are the data frames? It is 0, 1, 0, 1, and 0, 1. Okay. Now, so the first frame, what is SN? SN is nothing but the next. N is nothing but the next frame. Okay. So again, these are networking jargons. So you may remember this, you may not remember this. It is completely up to you. Okay. So SN means nothing but the next frame that the sender needs to send. Okay. So S stands for sender, N is the next frame that it needs to send, R stands for the receiver, and N is the next frame that it needs to receive. Okay. Okay. For the sender, the next frame initially that it needs to send is what? A 0 frame, right? So suppose the sender A sends a 0 frame. Okay. So after the receiver receives the 0 frame, what it will do? It will do two things. The first thing is it will send an acknowledgement. Okay. The second thing is it will just move the Rn pointer to the next bit. Why? Because why it will move to the next bit? Because now it is expecting the 1 frame, right? It has already received the 0 frame, no issues. Okay. But before receiving the acknowledgement, the sender will not move its pointer to the 1 frame because it has not received an acknowledgement for the 0th frame that it has already sent. Okay. Now after the receiver's acknowledgement, what is acknowledgement 1? Which means it is actually acknowledgement for 0, but now 1 means what? I'm trying to receive a 1, or I want to receive a 1. Okay. So ACK1 means acknowledgement for the data frame 0, right? And 1 means the value of the next frame that I want to receive. Okay. So after the sender gets this acknowledgement from receiver B, what it will do? It will do two things. The first thing is it will just shift its pointer to the next bit or next frame. Why? Because this is the thing that it needs to send now, right? And the next thing is what it will do? It will just send. It will just take this first frame and it will send it to the receiver side. Okay. Now the interesting thing happens here. Now the receiver. So whenever the frame 1 is being sent to the receiver side, suppose the frame 1 gets lost in transmission. Why? Because it's a noisy channel. Okay, it's not a noiseless channel. So since it's a noisy channel, it can happen that the data either may get delivered or may be lost during transmission. Okay. So suppose the frame 1 here is lost in transmission. Okay. Now what will happen? So let us understand another concept now. So whenever look at the first instance when sender sends the 0th frame. Okay. So again after sending the 0th frame, what it does, it will start a clock. You can see a diagram of a clock at the left, right? So it will start a clock, and for every transaction, or which means whenever a sender sends a frame, the sender knows the propagation time of the frame. Okay, what's the propagation time of a frame? It means the time required for a frame to go from the sender to the receiver and come back from the receiver to the sender. Okay, it's nothing like a echo, right? If you remember echo, that whenever you are shouting something in an empty room, right? What is the echo? Echo means nothing but your voice goes, the signal of your voice goes, it hits something, right? And it comes back to you. Okay. So the amount of time that the voice first came out of your mouth, and the difference between that time and the time when it again came back to your ear, that is known as nothing but the propagation time of your voice. Okay, and that is why we hear a echo, right? But again, whenever we are talking about data, every time sender sends the data to the receiver side, the sender knows that how much time, or the receiver knows, or the network knows that how much time a frame will take to go from sender A to receiver B, and again from receiver B to sender A. Okay. Now again, whenever the sender sends the data, it will just start a clock, right? And what is the and how much time will the clock be set to? It will be set to the propagation time. Okay. So within the propagation time, if the acknowledgement arrives, it's fine. Okay. But again, within the propagation time, if the acknowledgement does not arrive, then let us see what happens. Okay. So again, whenever it sends the first frame, you can see that it has started a clock. Okay. After starting a clock, it has sent the frame, and after waiting for some time, it is understanding that okay, I have not received the acknowledgement. Okay. So what does it think? It thinks that either the frame that I have sent is lost, okay, or the acknowledgement that the receiver B has sent to me is lost. Okay. So one of the two things can occur. Okay. So what can I do next? So to be on the safe side, I will restart my counter again. You can see it is restarting the counter, right? And again, it is sending the first frame that it has already sent earlier, and it has not received an acknowledgement for that. Okay. So the frame for which it has not received an acknowledgement, it will just resend that frame. Okay, and after resending this frame, the receiver B again will do two things. The first thing is, since it has received the frame, what it will do, it will just shift its pointer to the right hand side, which means now it is expecting the 0th data, right? And it will send an acknowledgement 0. Why acknowledgement 0? Because acknowledgement is for the frame 1 and 0 is denotes the next frame that I am trying to receive, that I am expecting to receive. Okay, now after this acknowledgement comes to the sender side. So again you can see that the sender has stopped the clock. So again within the time period the acknowledgement has come. After the acknowledgement has come, what it will do, it will just shift its pointer to the right hand side. Okay, and again it will send the frame 0, the next frame. Okay, so again the second, let us understand the second scenario. So again whenever I'm sending the 0th frame, the sender is sending the 0th frame, what happens is it will again start a clock. Okay, so if you understand stop and wait ARQ well, the next protocols will be much more easier. Okay, so again when it is sending the 0th frame, the sender, what it will do, it will do two things or three things. For example, two things actually. It will start a clock first, right, and then it will actually send a frame. Okay, now after sending the frame, suppose the receiver has received the frame. Okay, so after receiving the frame, what the receiver will do, it will just shift its pointer to the right hand side, which means it now wants the first frame. Okay, it will send an acknowledgement ACK1. What is ACK1? That is, I have received the 0th frame, now I want the first frame. Okay, now whenever it is sending the acknowledgement, let us presume that the acknowledgement is lost during transmission. Okay, now whenever the acknowledgement is lost during transmission, now again what will happen is the sender is actually already running a timer, right? So obviously after some time the timer will expire, because after the propagation time the timer will expire. So whenever the timer will expire, what the sender will do, it will think that okay, either one of the two things has happened. What's the first thing? First thing is that either the data that I have sent to the receiver has not received the data, right, or the acknowledgement that the receiver has sent to me, so the acknowledgement is not received by me. Okay, so either of the two things can happen. So whenever either of the two things happen, what the sender will do, it will automatically resend the frame that it had sent earlier. Okay, so it had sent the frame 0 earlier, so it does not know what has happened. So what it will do, it will just resend the frame and it will restart its clock. Okay, now after this frame is resent, the receiver B will receive the frame, right? Obviously it was wanting a 1 because it has sent an acknowledgement 1, so it was wanting the first 1 frame, but it will see that I have received the 0th frame. Okay, so since I have received the 0th frame, this is a duplicate frame. So what I will do, I will just reject it. Okay, and it will try and analyze that why is the sender trying to send me a duplicate frame. So it may happen that the acknowledgement that I had sent earlier has not been received by the sender. So what I will do, I will just send the acknowledgement that I had sent earlier again back to the sender. So again you are seeing that it is sending the same acknowledgement that was lost earlier, and is sending the same acknowledgement to the sender. Okay, now again after the sender receives the acknowledgement, what it will do, it will shift the point to the right hand side. Okay, start a clock, send the data, and again this thing happens throughout the process. Okay, am I clear till this?
Yes, sir.
Okay. Okay, next is it's already 10:10, because if I start with go back and ARQ, I will not be able to complete it. Okay, so let us do one thing. We will discuss the last two protocols for noisy channels in the next class. Okay, because these things are require much more understanding. Okay, go back in and selective repeat ARQ. Okay, you can see that the diagram is getting busier every time. Okay, so this requires much more understanding, and after this we will start with the medium access control sub layer, in which again we will have these kind of unlimited protocols. Okay, so we will have to study each and every protocols every time. Okay, so let us stop at this point for this class, and in the next class we will start with the remaining part. Okay, so let me stop presenting first. Okay, so I hope whatever we have studied today is clear to every one of you. If not, you can ask me the question. I am here till 10:20, And if you don't have any questions, you can leave the meeting. You have your IMCRP exam code in our WhatsApp groups. So kindly give the exam. Exam is very important. Attendance is very important, right? So give the exams. Again, if you don't have any issues, leave the meeting. If you have, stay back, ask me the question. Thank you. Thank you, everyone.